unsorted array it is mixed, no obviously ordering. So we have another kind of sorting arrays. For example, 3, 6, 5, 2. This is an unsorted array. For example, 2, 3, 5, 6. This is a sorted array. And for example, 6, 5, 3, 2. Both descending order is also a sorted array. Or for example, cat, bird, or ant. This is also kind of sorted array if we consider the first character from C, B, A. It is some kind of sorted array. So one most important thing in the sorted array is that it has a unique key. Okay, the key could be from this larger and larger, or smaller and smaller, or ordering, descending ordering in the characters. Anyway, it has a unique key. The key is unique. In the unique key to decide the values, these values in the array. And the rational operators are defined. So this means sorted array. So it is very easily to understand that sorting is that we rearrange the elements into either ascending or descending order within the array. For example, here the first line is an unsorted array. Then this one and this one are both, we call them sorting in the ascending way or in the descending way. Both sorting, okay? That is sorting. So a sorted array is defined as an array where elements are in order, okay? Okay. So my first question is, can sequential search used in a sorted array? If yes or no, anyone know the answers? Can sequential search performed in a sorted array? Is that okay or not? If anyone knows, you can input your answers through our chat box. Yes, yeah, that's right. A sequential search can be performed on a sorted array, okay? So no matter this array is sorted or unsorted, sequential search can both applied because it just search from one step by one step. So any array it can perform. So but one thing is that if these items in array are sorted, then we can stop looking. If we pass the place where the item would be, where it represents in the array, this situation is that this item is not in this array. For example, if we want to search 4 in array, so we have a 3, 2, 6, 7, 10. We have this sorted array. And we will search from the first beginning and move to here and compare. Okay, each time you compare and move and compare. And you find you have already passed. If we have 4 in this sorted array, it's supposed to be here. So we have passed. So you can just stop and end. And you can output the results is that this non-element is not in this array. So if there anyone can come up more clever method to search in a sorted array instead of sequential search one check one by one, that was a very silly way, right? But very fundamental way. So if anyone can have any idea that we didn't search from one step by one step, if the array is sorted, what kind of algorithms we can design? So this figure is just to show us an example about the sorted array, okay? So when we design an array, we have different elements in the array. So we have the elements. And we have 6 elements in this array. So we have a length is defined as 6. And also for each element, we have a position, okay, from the 0. And add 1 until 5. From 0 to 5, the length is 6. So for each array, we have the position, we have the elements, and we have a length. So if the length, the maximum length of this list, so it is from 0 to maximum length minus 1, the position, okay? So this is just an example of a sorted array. And after the consideration, no one came up a clever way to search in a sorted array. Anyone? Let's think in another way. A very easy question. If you have a book, the number of pages of your book is in order. That is correct, right? The number of pages is always from 1, 2, 3, and ascending order, one by one. So if you are searching a number page like 43 in a book, you will never check one page by one page. What did you do to find the page 43 in the book? You probably know. If you know the length of your book, how many pages that this book, how is that very thin or is that very not thin, then you probably know 43 is probably in which position, and then you just search in that kind of position, right? Is that okay? Usually if I teach this in my class, I will show you a book and show you this very easy way to search your number pages, but I think all of you know what I mean. So if you find a page in your book, in fact, you can check from the half, right? You can check from the half. The book in my page, the half is 133. And then you would know the number you search is in the left half or in the right half. It's smaller than the half one or larger than the half one. Then the length of the searched array decreased to half. You throw half of the unnecessary or unuseful data away. So you decrease the tasks you need to observe. So then we can check one more time half of this 133, half again. Then it is around 70. So we check it is smaller 70 or larger than 70, and we can throw half of them one more time. So obviously it is smaller than 70. So we can get half of the 70 is 35. And we will find it is between 35 and the 70. So one more time, the problem is divided into half. So if we do sequential search, it is a linear complexity. But if we use this kind of search algorithm, it is a log 2, right? Always your problem are divided to half, until very small. So the complexity is decreased greatly.